We're back to do the next 5 questions on the practice test. This question says solve the equation absolute value of 3x plus 4 minus 3 equals 13. Now, with an absolute value equation, you have 2 scenarios that you want to break down your equation to be. However, before you do that, you need to make sure that you isolate the absolute value first. So I'm going to add 3 to both sides, so that absolute value is the only thing on one side. Then we have on the right-hand side 13 plus 3, which is 16. And now we can break it down into the 2 cases. Our 2 cases are that absolute value of 16 equals 16, and absolute value of negative 16 is 16. So what that means is that this expression that's inside the absolute value could be 16 or it could be negative 16. So let's write those 2 scenarios. 3x plus 4 equals 16 or 3x plus 4 equals negative 16. Now let's solve each of these equations. I'll subtract 4. That's 3x equals 12. Divide by 3 and we have x equals 4. We'll subtract 4 and that's 3x equals negative 20. Divide by 3 and we get x equals negative 20 over 3. These are our 2 solutions to the absolute value equation. On this next question, we want to solve this system with the addition method. Sometimes the addition method is also called the elimination method. Our system contains the equations negative 9x plus 8y equals 68 and x plus 3y equals 8. Now with the addition method, first you want to make sure you have your like terms lined up. We have our x's lined up, our y's lined up, and our constants lined up. Most importantly, you want to have your equal signs lined up so that when you add the equations together, you're adding equivalent sides together. Once you have everything lined up, you want to decide which variable you want to eliminate. You can eliminate x or you can eliminate y. In this example, because we have an x with a coefficient of 1, it's going to be easier to eliminate x. Although you can eliminate either variable, and like I said, if you have a 1, it's just a little bit easier to work things out. Now we're going to eliminate x, and we want the x's to have the same coefficient but with the opposite sign. So this one has a negative 9. I want this one to have a coefficient of 9. To make that happen, I'm going to multiply by 9 on both sides of the equation. So if I do that, my first equation is not going to change. It's negative 9x plus 8y equals 68. The second equation becomes 9x plus 27y equals 72. So we multiplied a 9 on both sides of the equation to make sure the equation was balanced. Now we're able to add the equations together. Negative 9x plus 9x is 0x or 0. 8y plus 27y is 35y, a positive 35y. And on the other side we have 68 plus 72, and that's 140. So we've eliminated the variable x and we're able to solve for y. 35y equals 140. We'll divide both sides by 35. And 140 divided by 35 is 4. So we have y equals 4. That gives us the y coordinate of our solution. The solution is going to be an ordered pair. And now we need to find the x-coordinate. So we're going to substitute this y of 4 either into this equation or this equation. It doesn't matter which one. I'll do to the second equation. We have x plus 3y equals 8. X plus 3 times 4 equals 8. That's x plus 12 equals 8. I'll subtract 12. And x equals 4. Negative 4. So the solution to this system is negative 4, 4. You'll notice that I made sure that we wrote our solution as an ordered pair, the x and then the y. So we wrote the negative 4 first and then the 4. On this next example, we want to graph the system of inequalities. The inequalities are negative x minus 2y is less than or equal to 4, and x minus 3y is greater than or equal to negative 3. When you graph a system of inequalities, you want to graph each inequality on the same coordinate plane. Our first inequality is negative x minus 2y is less than or equal to 4. But when you graph an inequality in two variables like this, you have two parts. You start by graphing the boundary. And the boundary is the same except for you change the inequality symbol to an equal sign. It's negative x minus 2y equals 4. So you can graph this line by plotting points, by finding intercepts, using slope-intercept form, whatever your preference is. So I'll use slope-intercept form. I'm going to add x to both sides to get negative 2y equals x plus 4. Divide by negative 2, and that gives y equals negative 1/2 x minus 2. Now that it's in slope-intercept form, I can see that I have a slope of negative 1/2 with a y-intercept of negative 2. So to graph this boundary line, you either want to graph the boundary line as a solid or a dashed line, and you know which one to draw based on what inequality you have. The boundary line, remember, is equal to, and if you have the equal to in your inequality, you would draw your boundary line as a solid line. Solid line means that the boundary is part of the solution. So in this example, because we have the equal to, our boundary line is included, and we'll draw that with a solid line. So we plot our y-intercept of negative 2, use the slope to get to a second point, rise over run, so I'm going to go down 1 and over 2. We're connecting these points with a solid line, and we've drawn our boundary. Once you've drawn the boundary, then you want to do the shading. Now to do the shading, you want to choose a test point. And you can choose any ordered pair you want, except for ordered pairs that are on the boundary line. Most people like to choose 0, 0 as the test point. You're going to substitute that test point into your inequality. We have negative 0 minus 2 times 0 is less than or equal to 4. The whole left side is 0, less than or equal to 4, and we check to see, is that a true statement or a false statement? 0 is less than 4, so that's true. So going back to our graph now, here's where our test point was. Our test point is above the graph, and it came out to be true. And since we're looking for solutions to the system of inequalities, we are looking for ordered pairs that make the inequalities true. So we're going to shade the true side. The other side of the line would be false. So if I were to test a point over here, I would get false. Okay, we've drawn the first inequality, and we also want to draw the second inequality. The second inequality is x minus 3y is greater than or equal to negative 3. So we follow the same process. Draw the boundary line, which is x minus 3y equals negative 3. This time, let's use a different technique for drawing the line. Let's find the intercepts. Find an x-intercept by letting y equal 0. X minus 3 times 0 equals negative 3. So x equals negative 3. There's my x-intercept. To find the y-intercept, I let x equal 0. I have 0 minus 3y equals negative 3. Negative 3y equals negative 3. Divide by negative 3. And y equals 1. So a y-intercept of 1. So we want to draw this boundary line, and once again we need to decide whether to draw the boundary line as a solid line or as a dashed line. Our boundary line is equal to, our inequality has an equal to, and so we're going to draw this boundary line as a solid line to indicate that the boundary is included. I'm going to plot my x-intercept of negative 3, my y-intercept of, should be a positive 1, and we're going to connect those 2 points with a straight line. Once we've done the boundary line, then we figure out the shading. We're going to choose a test point, and we can choose any test point that's not on the line. So I'll choose 0, 0 again, and we're going to substitute it into the inequality. 0 minus 3 times 0 is greater than or equal to negative 3. We get 0 is greater than or equal to negative 3. And that is a false statement. 0 is not greater than or equal to negative 3. So this time our test point is right here, and it came out false. The other side of that line will be true. And we want to shade the ordered pairs that are true, so we're going to shade on this side of the line. So then finally, we want to determine the solutions to the overall system. Solutions to the overall system are going to be in this region here, where the two different colored shadings overlap each other. So this region contains ordered pairs that are solutions to both inequalities, and we also want to include this boundary line as well as this boundary line in the solution set. Simplify. Write your answer without negative exponents. Assume that no denominator equals 0. We have a to the negative 2, q to the 4th m, a to the 5th, q to the negative 3, m to the 8th, all that in the denominator. So one of the first things I like to do is to remove the negative exponents. And to do that, you just need to move your factor to the opposite of where it is. So if you have the factor in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And that's because having a negative in the exponent means reciprocal. So this x to the negative 2, I'm going to move that factor to the denominator to get rid of the negative. This q to the -3, I'll move that to the numerator to get rid of the negative. So that will give q to the 4th m q cubed over a squared a to the 5th m to the 8th. Now once I've done that, I want to combine any factors that have the same base. So I have q to the 4th and q to the 3rd. Those are both in the numerator, so those are multiplied, and we're going to use the product rule for exponents. Well, the product rule for exponents says this: if you have a base to a power multiplied by the same base to a power, you can simplify by adding those powers together. So b to the m times b to the n equals b to the m plus n. So I'm going to combine q to the 4th times q to the 3rd to become q to the 7th. I also have a squared and a to the 5th that are both on the denominator, so those are multiplied together, and we can use the product rule on those two. A squared times a to the 5th, we add those exponents to get a to the 7th. And finally, we have two factors with the base of m, and one is in the numerator and one is in the denominator. So I'm going to use the quotient rule for exponents. And the quotient rule for exponents says that if you have b to the m divided by b to the n, so you're dividing with the same base, then you subtract the exponents, m minus n. So if I combine m to the 1st power with the m to the 8th, I'm going to do so by subtracting those exponents. We do 1 minus 7, 1 minus 8, and that's a -7. Q to the 7, m to the -7. You'll notice that when I combine those together, I put that in the numerator. So you see when I did the subtraction here, this is in the numerator. But we want to write this without any negative exponents, so my last step will be to move this to the denominator to get rid of that negative exponent. So that's q to the 7th over a to the 7th, m to the 7th. Perform the subtraction. We have 7x to the 5th minus 5x squared plus 4x minus x to the 5th minus 2x squared minus 1. So we want to remove these parentheses in order to combine like terms. So to decide how to remove the parentheses, we can look inside, and we'll notice that inside we don't have like terms, so we can't remove the parentheses by doing the operation inside. And then we look to the outside of the parenthesis. Here we have nothing in front of that parenthesis, and so I can remove these parentheses without really doing anything. We think of this as being 1 times what's in the parenthesis, and 1 times 7x to the 5th is 7x to the 5th. 1 times -5x squared is -5x squared, and 1 times 4x is 4x. And so you can think of it as just getting rid of the parentheses or dropping the parentheses instead of going through that multiplication process. However, in the second set of parentheses, you can see that we can't do the operations inside the parenthesis because they're not like terms, And if we look in front of the parenthesis, we have this negative. So to get rid of the parentheses, we will have to distribute -1 to every term inside the parenthesis. -1 times x to the fifth is minus x to the fifth. -1 times -2x squared is a plus 2x squared. And -1 times -1 is a plus 1. Now we can combine the like terms. We have 7x to the fifth minus x to the fifth. So these are the like terms I'm combining. And that's 6x to the fifth. And we're going to combine the -5x squared with the 2x squared to get -3x squared. And the 4x doesn't have any like terms, so we'll bring that down. And the 1 doesn't have any like terms, we bring that down. So our subtraction gave us 6x to the fifth minus 3x squared plus 4x plus 1. Thank you for checking out my videos. Have a great day.